Um, What's up, YouTube? This is Greg from GregsTutoringNYC at gmail.com. Check out my website if you haven't. I'm a tutor located in New York City, and I'm going over some hard math problems for elementary school, so grade levels 3 to 8. We're currently going over some of the grade 5 ones. We're doing a part 2 to it. So let's see what we can get going. I did grade 3 and grade 4 already, and I did a part 1 to grade 5. Hello, I see some people coming in. Give me 1 second. I'm just trying to make sure we are live. Okay, we are live. All right, let me keep this going here so I can watch the chat from my phone. How's everybody doing? Pandemic tutoring still continues. So you guys are starting to finish up your school year. And this week is these New York State math tests. So that was half of the inspiration of my doing some of these videos. I've actually wanted to do these for a couple of years and just never got the time to do it. And I figured now is an opportunity for me to do it. So what I'm looking at is what I'm defining as hard math problems. These are problems that most kids could not finish on the New York State test. They got them wrong, they didn't know what to do, stuff like that. So what it is, I went through all the past New York State tests for about 7 years or so and looked for the hardest problems that they were and just ranked them backwards. And for each grade, that's how we're doing it. There is other definitions of what's harder. Like you could say exponents is harder than multiplication. I'm not really getting into that. I'm just going into problems that kids got wrong. So I'm making an assumption that they're hardest. And what we want to do is, as we're looking at each problem, we're going to look at it from a numeric perspective. We're not just going to look at the raw problem. We're going to analyze it, talk about it, look at alternatives, things like that. And as I increment along the grades here, it's going to get harder and harder and harder. Now, the New York State test has a problem to the extent that it's really testing you on roteness, memorization, and your knowledge. Okay? There's other standardized tests, like the SAT is a traditional one, that's going a little above and beyond that, where it's trying to test your reasoning and your critical thinking, and quantitative and qualitative things, and all these kind of things, your logic flow, and can you interpret a word problem into the math. Now this partially does that too, and that's the reason why some of the kids are getting some of these wrong. So that's what we're going to do here. Peace in, everybody. I see a whole bunch of people in the lobby. Welcome. So you can ask questions and you can chat. What I suggest and welcome anybody who's going to catch us on the replay. Please subscribe to my channel. As you see, I have hundreds of videos up already of various topics. Many are math related and many are ELA related. Many are high school admissions related. So I divvy things up in different ways. I tutor and homework help. I also specialize in admissions tests like the SSAT, the ISEE, the TACHS, the Bergen County Academies test, the SHSAT, the Specialized High School Test for Admissions to New York City, the Boston schools, the Chicago schools, a bunch of schools in New Jersey. And there's a kind of a common thread among them all, and kids consistently make some of the same errors. So that's kind of my another motivation for doing some of this series of videos right here. All right, and for now we're focusing on multiple choice questions. Depending on my availability and yada yada, I might do a part 2 where I now going to analyze the show your work questions to some of these tests that kids also got their worst effort on, which is its own issues. That's even another complication level on top of it. But at the end of the day, what we want to focus on is can we read a problem and can we solve it, right? So we're going to talk about problem-solving strategies, alternate ways to view things, and it comes down to your mastery of math, right? Your fluidity, your numeracy, and using what you know in ways that you never thought you could, right? So the point is, like, you might get taught multiplication. Well, then what, right? Then what? You're taught the area of a room. Well, if I need to paint the bookshelf behind me there, I need to figure out its dimensions and how many cans of paint I need. So there's practical uses for a lot of this, and you need to know what to pull out of your mathematical toolkit to solve these different problems. Because if you need to paint your wall, you need to figure out how much paint to buy and how much it'll cost you. And one thing does something else. And if you want to add a tint to it, it might be a different color and a different price. So this is really what it's all about. You need to balance your checkbook. You might eventually trade some stocks. Whatever the case is going to be, you're going to discount on a product. This is real world stuff. It's not just hypothetical. This includes pretty much all your math classes. A lot of you guys, this is kind of a good grade or age to say this at, like, what's the use of this, yada, yada. I hate math. Part of it's dealing with you're not understanding it. Another part is you may have horrible teachers and be in a bad school. There's a whole plethora of things here. So hopefully I can give you some insights and techniques and alternatives to viewing a lot of these things. Okay, so with that in mind, let's try to jump right in here. Each session I'm doing here is going to go about an hour. I'm not saying it can't be 2 hours or an hour and a half, but you know, that's really where I'm kind of shooting for, so that these are not painstaking kind of lessons. And I like to view learning as fun and exciting, and not something to freak out over and not something to panic about. And a big thing, especially since we're using state test as our guide here to go through the problems, basically, is that you know, if you're going to freak out, you're going to have a problem. So as much as some of this might be about solving math problems, it's also about a whole bunch of other issues. In this case, like, are you a good test taker? Can you pace yourself if it's a time test, and so on? You know, that's independent, and that's in addition to, like, looking at problem number 8 and analyzing it. Even if you had infinite time, are you able to rip it apart, the English words, and then map them into math and make sense out of it, and then pick the answer? And this is also a grade level where even though we're going over multiple choice questions here, you should often try to solve a multiple choice question as if you didn't see the answers, and then see if it makes sense to double check it. Okay, because enough kids don't quite know how to solve the problem, and they go down and use the answers to kind of guide them and force them into that. That's not really a good way to look at it. All right, let me just check one more time that we're live, and then we're going to jump into this. All right, there we go. It looks like we're good. Okay, so there is no illustration here. When I run into a problem, I like to look at the illustration first. Like problem number 9, which we're not going to discuss, I would not read the words. I would go right to that chart and try to figure out what is that chart about, and then go back into the words. Because when you do it the other way, when you look at the words, you're losing information. You're forcing yourself to think about what the words mean. Instead, there's a data table there with some pretty valid stuff in it, and you need to rip apart the title of the chart and each column and what its significance is and how each of the little cells here interacts with each other and so on. Same as if it's a histogram or a pie chart. You want to understand that illustration, or otherwise, why are they giving it to you? Also, on the flip side, in many word problems, you want to actually draw some sort of illustration of some sort. It could be a table like this, could be a pie chart, could be a histogram, right? Don't do things in your head on tests like this. You want to visualize them, okay? And it doesn't mean your numeracy. It doesn't mean to visualize and do every last thing. Like I used an example the last session. You had 12 times 10. You know, you don't need to write 12 times 10 in your paper. You all had better know that's 120, right? So your numeracy of that is so high that there's no reason that you need to doubt that anymore. It's the same when you first learned your multiplication table. That was pretty hard, okay? You got to memorize depending on what you went up to. And I suggest you all memorize at least up to 12 by 12. And enough of you still don't know it at grade 5. You must. It's holding you back like infinitely by not knowing it. And even if you can do it okay in your fingers, you're still holding yourself back. So these are things that are challenges, but they're overcomeable. And enough of you probably know 5 times 5 is 25, but when you were in the first grade, you probably didn't know that. And when you learn to multiplication, they're, oh my God, I had to memorize that. But now you know what it's. You can snap your fingers. It's, 8 plus 8 is 16. That's it. You're not even thinking about it anymore, right? So that's the level you want to get some things at, so those rote parts can just fall into place. Okay. All right. So let's jump into 8. So the value of the digit in the hundredths place of this number here is 1/10 the value of the digit in the thousands place of which number? Okay, so we saw a couple of problems like this already. I think there was one in the first part of grade 5, and I think there was also one a little less severe as this in the grade 4. So this is a standard question, and again, most kids got this question wrong. So the value of the digit in the hundredths place of this number, which digit are they talking about? This is the hundredth digit, the 8, right? So that value is not 8. This value is 800. It's not 8, it's 800. Okay? So it says the value in the digits of the number house of this is 1/10 the value of the digit in the thousands place of which number? Right? So 1/10 of some number is 800, is what this is saying. Right? This digit 800 is 1/10 the value of some other thousands place digit. So this is really asking you which of the answer choices has an 8 in the thousandths column. And that would be this bugger right here. So this is a no-brainer. It's A, and let's just double check. It's not. That's 9. That's 4. That's 7. All right? Now that you know that's what that's saying, go back and reread the words. Try to make logical sense out of this, because this is not normal phrasing. You could argue it's even foreign or obtuse, right? It's not kind of the normal way of speaking. And it's almost written slightly backwards and kind of like Yoda speak, right? I'm not even going to try to draw him. Yoda speak. All right. So go and process that and try to fit that back in now that you can see that's the way it is. So that when you see a problem like this again, first of all, you will most likely see a problem like this again. Okay, and it's talking about place value. You learned that probably in 2nd grade, but now they're giving a little twist to it here. Okay, so I'm spending extra time on this because these is your fundamental core math things, and if you can't get these, imagine a more complicated word problem. It's going to blow your head off, right? So you guys need to be careful with stuff like that. Okay, this is a very confusing problem. And a lot of kids got this wrong, and almost rightly so. And let me do something here for a second. Let me shrink the screen down a bit, because I have stuff blocking my screen, and it's not showing the answers to it. So let's do that one time. Can we get everything on the screen that way? Yes, we can. Okay. Because it's not showing on your guys' screen either. Okay, so this is a very weird way of expressing something. The good news is you're rarely going to see this in your math classes, on the test, or even kind of in real life. So it's basically asking, I said we go and look at this thing first. That's what the question is. It's saying, what the heck is this? There's a something by something grid and square or rectangle. Part of it's shaded, and part of it has X's in it. And part of it has shades and X's in it. Okay? And that's really what it comes down to. So looking at this raw by itself, it's hard to understand what to do with it. I gave other examples of illustrations in all these series and a lot of my videos where I show you how to analyze it. But this is presented like what is it, right? It's just this kind of weird thing. Of course, now I have hiccups in the middle of this. Again, if you guys in the lobby have questions, please go ahead. I'm happy enough if people just want to hang out in the lobby, that's cool. But if you have questions and so on, feel free to ask them. Even if you have questions that are not appropriate to what I'm talking about, I'll answer them at the very end, or I can email you with something if you give your info there. But especially if it's what I'm talking about, please definitely ask. And what I was going to say earlier was, if you're catching this on the replay, pause the video, try to solve it yourself, and then listen to what I say about the solution. All right, try to make it fun and enjoyable and things like that. So, all right, so we don't know what to do with this, so let's just start with the words. The decimal grid, this is a decimal grid, whoa, right, is shaded, right? So we have the shading here, and marked with X's to model an expression. And this is what I said already. Which expression could be modeled by this decimal grid? Okay, so why are they calling it a decimal grid? So let's just try to figure this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 going down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 100 squares here. All right. And some of them are shaded and some are not. So it's still unclear what the heck can we even do with this, right? So if we look at only the shaded part, right? This part here, I'm gonna just kind of draw through it. In fact, let me do that. I'm gonna get rid of the black line there. And so this whole yellow part is the shaded area, right? So how much of the grid is that whole shaded area? Well, there's 8 rows of 10, so there's 80, and there's 20 not there. So this is 80 out of 100. Now I notice none of the answer choices has that, but that's the same as 0.80. And I don't know that I see it there, but it's technically the same as 0.82. Okay, I don't see that choice there, so it's not going to come into play here, but you should know that equivalence is the case as well. All right. So then what we have is I'm going to highlight stuff in green now. We have this here now. This whole part. So for the yellow, for the shaded area, we kind of look going this way. Okay, for the X's, we're going to kind of look going up and down this way. So if you notice this 10 fours, so the X's are 40 out of 100. Okay, or 4 out of 10, so that's 0.40, or just 0.4. Okay, so what they're trying to get at, and let me now change the pen to red, is what is this right here? The overlap. Okay, what is that right there as a mathematical expression? So this is pretty whacked out, right, guys? So which expression could be modeled to do that? Okay, so first of all, we know it's not 0.08 and it's not 0.04. Okay, it's not 0.08, but it is 0.4, so that's no good. So this is no good, that's no good. It is 0.8, but it's not 0.4, so that's no good. And we're left with 0.8, which is what we originally said here, right? And 0.4, which is what we originally said over here, okay? And if we actually multiply this out, 0.8 times 0.4, right? We get 32, and we move the decimal place over 2. So we end up getting 32 hundredths. And if we count these, there's 8, 16, 24, 32. So that shows that that's a visualization of how this multiplication works. And that's what a decimal grid is about, okay? So we just double checked it by actually doing the multiplication and counting it. So what we're looking at is the overlap of the x's and the shaded area, which is now what I'm calling the red area. So this is a weird question. A lot of you never saw anything like this before in your life. It's not hard. Now that you know how to do it, it's easy peasy, right? Okay. Okay, again, this is a classic math problem for you guys. It comes up so much, and students just repeatedly get it wrong. And the good news for this problem is there's many ways to solve it. So Mia buys, so she has 5 yards of ribbon to make bracelets. She needs 18 inches of ribbon. So if the first thing you want to highlight is the yards and it's inches. So you might have to do a unit conversion at some point. So she needs 18 inches to make 1 bracelet, right? How many bracelets can she make if she uses all the ribbons she buys? All the ribbon she buys, I should say. So she buys 5 yards of ribbon. Each needs 18 inches. So 18 inches, if you know your conversions, 12 inches is equal to 1 foot, right? 36 inches equals 1 yard. Okay, and by the way, we showed some of the conversions that they give you guys. Where you're going to have some of that stuck in here. I put that down some here. I can't see where it is at the moment. Or maybe this is an older version. Here we go where it says length there, right? Okay, and if you notice, 1 yard then is also 36 inches. And 1.5 yards, I mentioned yesterday that this comes up a lot on problems. 1.5 yards is 18 inches. All right. So let's go back to the problem. This is floating around too much. So if 1.5 yards is 18 inches, and we can recalculate it by looking at these, that means that for 2 bracelets, right, if 1.5 yards, right, 18 inches is 1 bracelet, so 1.5 yards is 1 bracelet. So that means, sorry, since a yard is 36 inches, that means we can get 1.5 feet, I should be saying here. 1.5 feet is 18 inches, is 1 bracelet, right? So then 3 feet is equal to 1 bracelet, which means 1 yard. Sorry, I'm saying this wrong. 1.5 feet is 1 bracelet. Okay, 3 feet is 2 bracelets then. All I did is double this and double that. So that should say 2. Okay, which means 1 yard is 2 bracelets. So if 1 yard is 2 bracelets and she buys 5 yards, then she's gotten 10 bracelets. Okay, there's other conversions we can do here to do this, but that's the one that leaps out at me. Okay, you could also change this into inches and figure out how many divides into that. That gets ugly because they have to convert 5 times 3 and get 15, 15 times 12, and then that divided by 18, it gets pretty ugly. All right, so what you need to do is, and it's not that it won't work, it will work. Just that this is the solution that leaped out to me. All right, and that's an alternate way to double check it, by the way. So again, you have a lot of variability on that problem, on how to solve that one. Okay, most kids got this question wrong too, and it could be because of the way it's set up. Okay, so I often say to look at the illustration first, which is going to be this here then. That's the illustration, the whole expression there. And just looking at the boxes, it may not leap out at you that they're looking for an operation here, let's say plus, okay? And they're looking for an exponent here, like in the number 2, okay? So that's what's going on here. So this should be an operation, and this is going to be an exponent. And that's what they're looking for. A lot of kids may not even know what the squares were there for. And in some ways, they should have explained that. On the same note, if your fluidity and numeracy and so on is, you have your A game on, it should leap out at you that that's what's going on there. All right, so now that we see that we have 7,320, something 10 to the something equals 7.0732, whatever. All right, so they're probably trying to convert the left side of the equal sign into the right side. So we have to figure out how that might come about. So it says the operation symbol, that's this box here again, and the exponent, so that's that box, are missing in the equations shown below. So that may not even be enough for enough kids. So again, once you see this, keep this in the back of your mind that might be what they're looking for. Okay, so then it says which operation symbol and which exponent should go in the boxes to make the equation true, right? So what we want to do is focus on the 7,320 and this number here. So the question is, how can I convert from here to there? Okay, what do I need to do that? So a little gotcha is the comma there. So what we're really asking, just to be clear, is if I do 7,320, okay, how do I get it to be 0.0732 and 0, they put a 0 here. Now it turns out that the 0 at the end of a decimal number, it doesn't matter, okay, and the 0 here doesn't matter either. So in an odd way, we can remove those. I'm going to put the X on top of them because I don't want to clutter the screen. We could remove them. The problem's the same. Okay. So what do we need to do to get this number A to be this number B over here? Okay. If you notice, any number is itself like that, right? This is still the same value. 7320 is an integer, and 7320.0 has the same value. It's still 7,320 or something. So how do we get this to be that? So if we move this decimal here once, twice, 3 times, 4 times, now we have 0.7, and 1 more time and add a 0. Okay, so what do we do? 1, 2, 3, 4, 5. We moved it 5 times. So when we go to the left, we're doing division. Okay, so which one would be division? So in other words, if we come back to the original thing over here, 7230 divided by 10 to the 5th equals that. So that would be D, right? This is a weird way to structure it. It's symbolism. Mathematics has notations, and this is part of what they're asking you to do. So the first thing up on the plate was like, what the heck are they even throwing at me again? Once you realize, oh, they want an operation in there, and they want an exponent value in 10 to the something, then now you're going to switch into how do I do the conversion of the number from a whole number to a number with a decimal point. All right, and then technically, you learn things like scientific notation and things like that. So this is moving towards that direction. All right. So this actually wasn't hard. A lot of you just do not know your conversion rules of how to move the decimal over, though. All right. All you do is count. Remember, 7320 is the same as 7320 dot. Right. And even this 0 here, even though I wrote it, it didn't matter. The dot is what mattered. And it matters how many times to the left you moved it so that it gets the same point that it is on this number over here. And you had to move it 5 times to do that. Okay? And we can even come back and show it on the second number. Because if I move the point from here, it's 1, 2, 3, 4, 5, right? And I started here because we have the root number here, 7230. All right? So that's what's going on there. That's what's up. Okay, let's just make sure we're live. Again, welcome everybody. Please join in if you want. Again, as usual, please like and subscribe. We're here to share with each other and just enjoy what's going on, right? So if you guys have questions, please ask. All right. We look like we're live. And we're about halfway through with this, I believe. How are we doing on time? We're about 40 minutes. And I think we have about 5 more questions, I think. Could be wrong. But some might be doozies, too. Doozies. They could be doozies. Okay, so here's a straight up pure word problem. Yay! Right? So we're going to take it a sentence at a time. A science teacher has 0.4 liters of seawater. Oh, yeah. Whoops. Let me get rid of that. Let me fix that, guys. What just happened there? It's not fixing itself? Let's do this. Wait. Okay, there it goes. Has 0.4 liters of seawater. Okay. And I'm seeing milliliters and stuff in the place. So this is probably going to come into play. If you remember what I was showing you guys yesterday, 1 liter equals 1,000 milliliters. Yeah. And then let's see what flows from there. So a science teacher has 0.4 liters of seawater. She gives each of her 22 students a 0.5 milliliter spoon. Yeah, no problems, right? This is easy peasy to now. She then asks her students to put 2 spoonfuls. Remember from yesterday, some numbers they're going to give you as digits, and some numbers they're going to give you as words. That means you need to be astute and be keeping track of them. So she gives each student, tells each to use 2 spoonfuls of seawater and their containers. So a kid has a container. Okay, there's a spoon. That's 5. Okay, 5 milliliters. The kid's going to put one of them in. So that's 5. The kid's going to put a second one in. That's 5. So that means there is 10 in each beaker or container or whatever the kid's has, right? Yeah? Yeah? So now the question is, she then asks her students, but how many milliliters of seawater would be left after all students have filled their containers? Left from what? Well, the original 0.4. Okay? So what we need to do is if 1 liter is 1,000 milliliters, then how much is 0.4 liters? Right? And that's the same as 4/10. So that would give us 4/10 of a liter, right? And we can multiply the 1,000 by 4/10. Okay? 10 goes into here, we throw it as 0, and we get 400. 400 what? 400 milliliters. Okay? So we rewrote the problem. The teacher had 0.4 liters. Now the teacher, this is what the teacher has. The teacher has 400 milliliters. Okay? Okay? If each kid filled up the beaker with 10 milliliters, and there's 22 students, then that means there's 220 that the students used. So that's all we have to do is do 400 minus 220, and we get 180. Okay, which turns out to be B. Right, so this one wasn't too deep, although there was 5 parts to it. So get any one part wrong, and you messed up. Okay. I suppose some kids would add the 220 to the 400 and get 660, but that's not one of the possibilities here. So that's normally kind of what starts happening with this problem, is that kids do a miscalculation. They don't know how to get the right answer. So they end up getting something what they think is close, and they pick the number that's closest to it. But this is math, and you got to be exact. Okay. So that's the deal there. This one's hard. Another one that's hard to feed the answer back in because there was so many steps. We had to do this conversion. We had to figure out how many the students had altogether. We had to do the subtraction. So there's at least 3 major steps and a couple of smaller ones. Like we had to figure out the 5 plus 5 was 10 and things like that. So it was simple but busy. So this was a task to do. And remember too, when you're doing these things, just remain calm. Do each sentence one at a time. Think about it methodically. You should show your work. Write it all down. On a test like this, you're usually only going to be graded on your Scantron. So any work you do is for yourself. So that means you're allowed to put stuff down to kind of experiment with the problem and try to get a feel for it. So in the worst case, let's say everything I wrote on the screen right now was wrong. Well, all you have to do is put a big X on it and try it over. But you might realize like, oh, this part was okay, but it was here I made the mistake. So you can still have that down there. And by the way, don't erase things. First of all, do what your teacher says to do, because if your teacher's grading you and the teacher wants it a certain way, I'm not saying to get points off of that, but if this is a test, let's say this whole page is wrong. All I have to do is go like that. Okay, that's all I have to do. Okay, and I still have all of this space over here to redo it over. Okay, because what often happens is you start erasing stuff, you get the pencil on the side of your hand. You might rip the page. You have all this shredded eraser on your desk. It's just a whole bunch of stuff to keep managing. The main thing your eraser should do is to keep your bubble sheet clean if you happen to have one, right? I know I keep flipping into test mode even though we're talking about problems, but they're interconnected here. So what we're trying to do is get you to solve the problem and focus on solving the problem and not erasing the page and not worrying about if you ripped it or 1,000 other scenarios. Just cross it out and use the space from somewhere else. Okay? Wait 1 second, guys. I just got a message. Okay. Right. Okay, so we solved 42. Okay, this is a geometry problem, and it on its surface it seems fairly simple, but further on it's almost super duper hard. And most kids get this completely wrong. Okay? Out of all the questions we've seen from grade 3, grade 4, and 5, this is probably what most students got wrong, this question right here. So first of all, this is terminology and its shapes. So what does it mean to have 4 congruent sides? Congruency deals with the same size as in length and the same angles. So if a shape has 4 congruent sides, and there's a whole bunch of them, so they're asking you out of this choice here, which of these 4 has 4 congruent sides? Okay, so if the answer was like a triangle, it might have congruent sides, but that's called the equilateral triangle. Well, there's only 3 there, right? And you can't have 1 congruent side because there has to be at least 2. But if you had 2, that's not a closed figure, okay? And they're not saying it has to be a polygon here. It just says which shape, all right? So what we're going to do is kind of survey these things and try to determine that from that. All right, so let me get rid of some of the clutter on the screen here. So a parallelogram is a geometric figure where opposite sides are parallel. So if I had side A and B, that would be parallel, and C and D, that would be parallel. So does all parallelograms have 4 congruent sides? Well, this is a rectangle and it's a parallelogram, and it does not have 4 sides that are equal length. What does, though? A square. So it turns out that some parallelograms, and I'm going to put a little tick mark to indicate that they're the equal sides. Okay, I'm going to put a tick mark here. That's equal to that. And I'm going to put 2 there. That means the single is equal to single and the double is equal to double. So a square is, but this says always. Okay, so the answer is not A. I just discussed the rectangle. The only rectangle that has 4 congruent sides is a square, right? A rectangle is not a square, but a square is a rectangle. So for that same reason, B is no good. Okay, what is a rhombus? A lot of you don't know what a rhombus is. It's kind of that kite figure. And we tend to draw it like this, even though it doesn't have to be drawn this way. Okay, and if you want to look at it, it's almost a square on the side. In fact, squares can be rhombuses. So rhombus, by definition, has 4 congruent sides. Ta-da! And just to rule it out, a lot of you still don't know what a trapezoid is. A trapezoid looks like that. Okay? That's a regular trapezoid, at least. A trapezoid can also look like this. Okay? The side here, I'm going to call this A, and the side here B. It doesn't always need to have that slant. In fact, there's mathematical arguments that say a square can be a trapezoid, okay, depending on which definition you use of it, okay? But as we can see, this doesn't have 4 congruent sides, this doesn't, but this does, okay? So for that reason, trapezoid is not always. So we still end up with C. Yay, rhombus. So be familiar with your shapes, be familiar with terminology. You should also, in addition to congruency, also know about symbol shapes, okay? We're not going to talk about those here because no problem is dealing with that, but Okay, this is another one that for some reason it's traditionally on a lot of tests, and it's usually in your homework and the teacher will discuss it, but traditionally a lot of kids still get this wrong. Let me just see if this is fitting on your screen. Yeah, there we go. So we're going to look at the illustration first. We have something that kind of looks like an aquarium. It's a rectangular prism. You know, a cube with different dimensions. So it's not a cube, it's a rectangular prism instead of a square prism. We can see that the base is 8. The height along the left-hand side there is 5. The width, so to speak, is 3. And then they're showing something 1 inch high. Okay? So those are 1 inch cubes. Since the right-hand side is 3, it looks like that each of those is equally distanced, and they're also a 1 there too. So 1 plus 1 plus 1 equals 3. Okay, we don't know this. They're not guaranteeing us. It could be that the last cube is a 1/2 inch. The middle cube is like 2.5 inches or 1.5 inches, and the last one is 1. So it could be, 1.5, 1.5. We don't know. So they're not telling us, but they look like they drew it that way. You can't always go by what the drawing is implying. It has to say it. It has to say it somewhere, either in the directions, in the instructions that all figures are to scale and drawn properly, or not, okay? And then we have 8 across, and the same thing goes there. It looks like there's 8 across, and that's 8 inches, so it looks like these are 1 cubic inch squares, cubes rather, at the bottom there. Okay, so there's a layer there. So that means to me that, and I'm guessing this is where they're going to go with this problem without reading it yet, that we're going to need to use the 8. Okay, we're going to use the 3. And since this is 5 and this is 1, we're going to somehow have to compute this or use it for some reason. And we're going to know that this is 4. Okay? We also don't know, they haven't told us that the whole giant aquarium-looking shape is in fact a rectangular prism. But let's see what's happening here now that we kind of beat this to death. We can also go on the side here and compute some areas and so on, but that starts getting overkill, especially since we don't even know if these are truly cubes and that the whole thing is truly a rectangular prism and so on. So let's see what we have. The diagram below shows some 1 inch cubes placed in a box. So that's what it means, that each side of this, that this is 1, this is 1, and that the depth going back here is also 1. Okay, so this is 1 cubic, 1 inch cubes is the volume of that thing there. So it says how many more 1 inch cubes are needed to completely fill the box. Okay, so they actually didn't tell us anything about it. It would have been nice if they told us that like these are right angles and so on, but I guess we can apply that. It's something they should have told us. You could argue that, well, the bottom we know is guaranteed because they're all smacked up against each other, and if this is a right angle, and this is a right angle, and this is a right angle over here, and this is a right angle over here, and so on, that the side should be going straight up. Okay, so I suppose so. So it says how many more are there, right? So we can get the overall volume, that's 5 times 8 times 3. How did I get that? It's this full length here, this full 8 here, this full 3 there. Okay? So it's saying how many more? So what it's asking us for is if we filled this up with water here, everything above that cube, if we filled it up with water, whereas if that was cement at the bottom of those cubes, how much is the volume above those cubes? Well, that's going to be, let me change the pen back. That's going to be 4 times 8 times 3. Okay? And what's that going to give you? Right? 4 times 8 is 32. And then 32 times 3 is 96. So there we go. Bing, bang, boom. Yeah. Okay. So this is a traditional question. There's a lot going on here, but it's biteable. It's bite-sizable. Okay. And you can use this to calculate and go backwards and forwards with lots of different stuff, including composite stuff. Because let's say they got rid of everything here. They got rid of 4 rows here. We would just add that in, right? If we got rid of the green part here, what's the area then? It would be 96 plus what? Well, it would be 4 here. So that's 4. It would be 3 going back still, times 3. And it'll be 1 high. Whoops. Times 1. So that's equal to 12. So the volume of the water there will be 96 plus 12. Which is 108. Okay. I think we only have 2 problems left. Let's see here. Okay, 31. 31 is trying to understand whole numbers and fractions and things like that. So this is a simple question that's kind of mind-blowing to a lot of kids. So how many 1/3 cup servings are in 4 cups? How many 1/3 cup servings are in 4 cups? Well, how many 1/3 cup servings are in 1 cup? One-third cup servings in 1 cup. Okay, wouldn't it be 3? Right? Wouldn't it be 3? If there's 1/3 cup servings, right? There's a cup and it's only filled a third. If we did 3 of those, we would have a full cup, right? So that's where we're getting this from. Okay? And if there's 4 cups altogether, then this is 4 times 3 and the answer is 12. Okay? Okay? There's another way to solve this, which is the total number of cuppage that we have is 4. And we're going to divide that by 1/3. Okay? And what we can do is, there's another way to write this, which is that it's 4 divided by 1/3 this way. Right? And you guys should know, and we saw this problem yesterday, that division by a fraction is the same as multiplication by its reciprocal. Okay, and the 4 drops down. So 4 times 3/1, this is just the same as 3. Okay, and that's also equal to 12. Yeah! Booyah! Okay? Okay, this is a busy problem. Three boxes are shipped on a truck. So this is a classic word problem, I guess. 3 boxes are shipped on a truck. Ugh, big deal. Each box has a base of 16 square feet. So there's a box, and the base is 16. Okay, and let's just assume it's that should be a 6. All right, so let's assume it's hollow for the moment. But the bottom, this is going to be on the floor, is going to be 16. Okay, we know that's 16 square feet. So that's the area of the base. Area of the base is equal to 16. Okay. So 2 of the 3 boxes have a height of 3 feet. So that means that's this here. So that would be 3. Okay. And then it says 1 box, which still also has a base of 16. has a height of 5 feet. Interesting, right? So what is the total volume in cubic feet of the 3 boxes? Okay, so there's a couple ways to view this. Imagine if the boxes were next to each other, right next to each other. So the first 2 boxes are exactly the same volume, whatever they happen to be. Okay? So we know that we don't know this length here, right? And we don't know this length here. But we know that the multiplication of those 2 numbers is 16, because that's what the base is. So volume is the length times the width times the height. So we already have the length times the width, that's 16. So 16 times 3 is 48. Okay? So that's the volume of this box. And the volume of this box is going to be 16 times 5. Okay, and that's going to be 50 plus 30. So that's going to be 80. Okay? Did I do that right? 16 times 5 is 50. Yeah, that's 80. So we have 2 of these. There was 2 of those. So 48 times 2 is 96. Okay? So then what we can do is add 96 to 80, right? 176. So we get the answer B. And booyah again. We're good. Okay? So we figured out the key was realizing that we didn't need to know the 2 bottom numbers. And the funny thing is you could have made them up. We could have said the base was 4 by 4. Okay? We could have said the base was 2 by 8, right? We could have said the base was 1 by 16. It didn't matter what we chose, because as long as we multiplied those 2 numbers, we were still going to get 16. So all we had to do was adapt for the height. So once you adapted for the height, you had to realize that there were 2 of these kind of boxes and only 1 of these kinds. Okay? So that was kind of the clincher there. And it's involved. There's a lot to keep track of all the time. I have a feeling there was a question at the bottom of this page. Yes, there is. Ursula drew a polygon, so that's a closed figure, in which all the angles were obtuse. All the angles were obtuse. Okay, so this has kind of vagueness, which is all the interior. I'm going to just say int. So what am I talking about? Why am I talking about interior? Because let's say I drew a square. We like to talk about this being 90 degrees, but this angle here, that's obtuse, and that's 270. So if I said, what's the angle at point B over here? I have to say interior or exterior. There's 2 angles at point B. There's the inside one, which is 90. There's the outside one, which is 270. So they're talking about the interior inside one here when they're talking about that. Okay. So she drew a polygon in which all angles were obtuse. So you might think, wait, how can I do that? Because if I do, say, a triangle, then some of them. So let's go through the choices they're giving. So it doesn't matter what kind of a trapezoid we draw. It has to be true for all trapezoids. So that could be obtuse. That could be obtuse. But in this example, this is not, and this is not. Okay? So it's not A. A parallelogram, we could have a square. Okay? They're all 90. We could have a rectangle. Right? They're all 90. We could do something like this, where we kind of slant the rectangle, if you will. Okay. This is not obtuse. That's not obtuse, although this and this is. But since 2 and not, then the parallelogram is out. It doesn't work for a square. It doesn't work for rectangle. It doesn't work for that. Okay? A triangle, well, these all of these are smaller. If I make one obtuse, then the others have to be acute. So it's not a triangle either. And then a pentagon, right? A pentagon has 5 sides basically. Okay? So that is obtuse. That is obtuse. That is obtuse. That is obtuse. And that is obtuse. Yay! Okay? And by the way, it said could. I was assuming always all the time. So, but this said in which all the angles were obtuse. Which of them could have, or were they all? So even though we had like the trapezoid, this and this, they all didn't have it. Okay, it's the same with the parallelogram. Okay? All right, we have 1 or 2 more problems left. Yeah, I think I can get through it faster by doing this. Whoops. Where'd that go? Okay, so we're back to doing fraction kind of stuff here. On Saturday, Mark sold 2 7/8 gallons of lemonade. Okay, end of that. On the same day, Reagan sold 2/3 as much lemonade as Mark. How much lemonade did Reagan sell? So they're asking how much did this kid sell? So he sold 2/3 as much. That doesn't mean he sold more. All right? So if Mark sold 2 7/8, okay, that gives us what? We have 16 plus 7 is 23/8, right? And he sold 2/3 as much. So we get some slight nasty math. We can cancel this out and get 4. 2 goes into 2 once, 2 goes into 8 twice. So we get 23 over 12. Okay, and that's equal to 1 and 11/12. Okay, so I think the main gotcha for this problem, and again I can only guess, is that enough kids are thinking this means like 1 2/3 more. But this just means, so Reagan sold less. If Mark sold 5 gallons and Reagan sold 2/3 as much, Reagan sold less than 5. All right. By the way, that's the thing here. This is 2 7/8. This is 1 11/12. Okay. All right. So we have one more problem. Okay. So it says, what is the area in square feet of the rectangle shown below? Oh, actually, there's another problem after this still. So this one's just plain old nasty mixed fraction multiplication. So this becomes the question simple enough, and there's really nothing in the illustration to really analyze in any depth. So this is 34/5, okay? And this is 16, this is 19/4, okay? And really what we have to do is just multiply those out and then do the division. The answer turns out to be D when you do that, okay? So this just really just becomes that, right? This is 34/5, and this is 19/4. It says, what is the area? So we're going to multiply 34/5 by 19/4. Okay, and when you get 34 times 19, okay, and we can simplify that, or we can keep it as is, because if you notice, all the answers are in 20ths here, all right? Okay, so 34 times 19, right? You're going to multiply that out, and when you do that and you do the division with the 20, you're going to end up with the D there. I actually have somebody at my front door, a family member, so I'm going to try to zoom through this last question. How many more problems are there? Let me see. There's actually more than one problem. All right, I'm going to try to keep my family member waiting just a smidgen longer. Okay, so this is one of the ones we saw yesterday, where you just read the sentences, you take it a sentence at a time, you feed it in with the bullets as well, okay? Carlos makes 1 pound of snack mix using nuts, raisins, and cereal. The list below shows how many pounds of nuts and raisins he uses, okay? So altogether, he makes 1 pound of the mix, okay? So if he uses 1/3 of a pound of nuts, plus 2/5 of raisins, okay, plus the cereal, he's going to get 1. So this is just about combining fractions and doing the subtraction off of 1. So we're going to get a common denominator, okay, which is going to be 15ths, plus the C, right? And then 1 is 15/15ths. Okay, so 1/3 is the same as what? 5/15ths, right? 2/5 is the same as 3, so we get 6. Okay, so these collapse to 11/15ths, right? Plus C equals 15/15ths. We subtract 11/15ths from both sides, and we get, we get C equals 4/15ths, which turned out to be choice number C over here. All right, so we just follow this methodically. I often like these kind of questions because they're that kind of smooth and that kind of consistent. Let me just double check to see how many questions we actually do have left. No, there's actually about 4 left. Okay, well, let's just see how this works out. Oh, and by the way, I wanted to go back to this problem for 1 second. The one with the area. So if it was just 6 times 6 and 4, you know the answer has to be over 24 for this question. So there's no way on earth the answer could be A. And because 6 4/5 is almost 7, and 4 3/4 is almost 5, we can almost do 7 times 5 and get 35. So we know the answer can't be even B. It gets a little queasier for C, but you can almost estimate the answer for this question. And this is another, so I'm mentioning this as a way to double check it. In other words, 6 4/5 is almost 7, and 4 3/4 is almost 5. Well, 7 times 5 is 35, okay? So the answer is getting close to there. Okay, now 7 is higher than 6 4/5, and 5 is higher than 4 3/4. But if you kind of back off a little bit, you should at least rule out choice A and B, even if you're not sure if it's C or D. And then you're down to 50-50 if you still don't know how to do it. But it's fraction math or whatever. Okay, I'm mentioning that because the question I just went to has a similar issue to it. Where did that question end up? Right here. So Cole has a rectangular garden with an area of 16.02 square meters. The length of the garden is 4.5 meters. What is the width in meters of the garden? So let's try to visualize this. We have a garden. The area of the garden is 16.02. Okay? Sometimes this is arbitrary, but if we make this the length and this the width, okay, they're telling us the length of the garden is 4.5. Okay, so now they're asking what is the width. Okay, if area equals length times width, and that's equal to about 16, right? And we know the length already is 4.5, okay, times W equals about that 16. We know the answer can't be D, it can't be C, and it can't be B, because 4 times 4 is 16. So 4, a little more than 4, times something a little less than 4 is going to be equal to 16. So the answer there, you can solve this without actually doing the multiplication. But the real way to solve this is to divide 4.5 into 16.02. Okay, and if we shift the decimal point over once, that means we're actually doing 45 divided into 160.2, right? So 4 times 4, 45 goes into 1, it doesn't happen. 45 goes into 16, it doesn't happen. 45 goes into 160, well, if that was 4, it would be 40 times 4 is 160. So it has to go into it 3 times, right? 45 times 3, you got 40 times 3 is 120, and 5 times 3 is 15. So that's 135, right? And we get, what, 252 there? Okay, so 45 goes into 25 here. 5 times will give us 225. So we bring the decimal point up. We get the 5. So 225. And we get 27 left over. We can add a 0 and drop it down. And 45 goes into 27. Well, 45 twice is 90. And 9 times 3 is 27. So 45 times 6 is 270. So we can actually do the division and actually get that too. All right, like I said, I have somebody at my door. They still haven't come in and they're texting me. I have another family member who's just about to arrive, but so I'm trying to go through this fast at this point. But you just basically have to do the long or short division there to do it, or use the intuitive mechanism I just showed you guys to be able to double check that, okay? Okay, so this comes back again to the standard thing I was telling you before about your conversions involving stuff. So what is the equivalent of 4,000 centimeters? Well, 1 meter equals 1,000 millimeters, okay? And if we went through what I showed you yesterday, once you know this golden rule, then it means 100 centimeters, okay, and 10 decimeters, okay? You could kind of just fill it in there. So the one we're looking at today is the centimeter one. So 1 meter, we can get rid of these because they're distracting us in the moment, is equal to 100 centimeters. So they're looking at 4,000 centimeters. So how many 4,000 centimeters are there at 100 at a time? Right? Isn't there 40 of them? In other words, if you do 40 times 100, we get 4,000. So another way to look at it is we're doing 4,000 divided by 100. So we're going to throw away 2 zeros, and we're left with 40, or the answer is B. Okay? So this comes down to just remembering your conversions and doing your division in the right direction. And again, this is a standard question, and it's one that kids keep getting wrong. And you must memorize part of this. This is not something you can do through osmosis or wake up that morning and say, like, I'm a centimeter master. You can't do that. This is something you have to sit down, memorize the table and the rules, at least the first one. Like I said yesterday, I only memorized the top line, that 1 meter, 1x equals 1,000 milli-x's. Whatever x is, it could be meters, liters, kilograms, grams rather, sorry. Whatever the unit is, it'll always work that one of the units equals 1,000 milli-units, okay? And once you do that, you know that 100 means centi, like century is 100, and deci implies dime or whatever, which is 10 cents. So you can always fill out the rest of them. Okay, now we're finally at the last problem. Okay, which expression is not equivalent to 4/3 times 8? So there's a lot of weird stuff here. What we're just going to do is 2 times 4, because 4 is the same as 4 over 1, right? So this is equal to 8 over 3. All right, so we're trying to look for something that's going to be about equal to this in some way, shape, or form. And if you remember what I was talking about yesterday, sometimes when you go from this, the expression in the question to what the actual result will be, like 8/3, there's no choice there that says 8/3. So we have to do is analyze each choice and see if it is 8/3, okay? So, and it's saying not. So 4 times 2 is 8, and this says 8 divided by 3. Well, that is what that is. So that means this is 8/3, so that's not the choice because it's asking for not, okay? This is 1/3 times 2 times 4, which is 8, okay? So that's also 8/3. So that's not the answer either, okay? So C says 4 times a third, which is 4/3, times 2, which is 8/3, okay? So C is not the answer either, all right? So then that implies D is the choice. So let's see if it actually is. So 2 times a third is 2/3. And 4 times a third is 4/3. Okay, and this is equal to 6/3. Okay, and not 8/3. All right, so there we have it. We went through the hardest problems for grade 5. Let me go back and make sure we're still live here. No, I lost the connection. Let's see here. No, we're good. All right, so I'll ask people asking SHSAT questions here as well. So I'm finished with the grade 5 stuff, so I'll tack this on at the end. Can I ask a question about discovery? How hard do you think the 9th grade SHSAT will be? The SHSAT is hard. What do you think the cutoff for SIT will be for 9th grade SHSAT? I think it was 519 if I remember off the top of my head. Can you do 7th grade hardest problems? Yeah, we're eventually going to get to that. Okay. And I'll do another SHSAT stream at some point, which will no doubt talk about discovery stuff. Discovery is for kids who didn't meet the cutoff for the SHSAT, and there's certain criteria. You have to have certain impoverishments, like you're might be home living in a temporary shelter. You might be an ELA learner who's only been here for a few years, or your economic situation is not too well. Also, your school has to have what's called an E&I index of 6 or above, I think it is, to indicate that you're going to an impoverished area in your school, so to speak. So there's things like that. All right, all right, all right, guys. Let's see. I can't end this because my browser freaked out. So give me 1 second while I'm still talking. So again, I'm Greg from GregsTutoringNYC at gmail.com. The next thing I'm going to do is the grade 6. I don't know when. Hopefully tomorrow, maybe even later today. I do this on my free time. So please be respectful of that. And hope you guys have a good week. You're going to have your state tests coming up. So good luck with those and good skill. That's one reason why I'm doing some of this. Please subscribe to the channel. I'm always doing these kind of things. Will I do it on Tuesday? I don't know. I don't know. The best I can do is what I can do. I'm only one person, and you know, this takes hours and hours and hours. This for grade 5 already took me 3 or 4 hours to do. So I just inch along each, making a progression. I have hundreds of videos to help kids in different ways, students in different ways. So that's the best I can do. If you have a specific question, you can always email it to me. I'm also a private tutor. You can definitely hire me and get straight up tutoring for that point as well. All right. I'll see what I can do though. I'm not saying no, but this is with my free time and so on. So if a group you want to pay me, I can certainly do a private one, or I could do it publicly. That's always an incentive as well. In the meantime, you know, I'm trying to do this for the benefit of everybody. All right, guys. Please subscribe to the channel. Please like the video, and peace out.